Ayan. Okay, sige. Excuse me. May I know lang din, kailan ba ang exam ninyo for this topics? Or meron na ba? Ano, natripan lang ba ng PSME na magpa-review? Wala pang sinasabi. Okay. Sige. So, isang section next Saturday. Okay. Sige. So, ang sabi lang sa akin ng PSME was, yun, daanan lang natin yung units 1 and 2. So, may na-prepare naman silang problems, a few problems siguro. I don't think we can cover all of them within 1.5 hours. So maybe po-provide naman siguro nila yung solutions dun sa other problems na makikita niyo dito, pero di natin madadaanan. Okay, so start tayo with the first order ordinary differential equations. So recall lang natin, differential equations are equations na may derivatives dun sa mga terms nila. So ayun, ginagamit natin sila sa pag-describe ng mga phenomenon na pinag-aaralan natin in engineering, dahil may mga bagay na mas madaling i-describe using derivatives. So ayun, short intro lang. So meron tayong iba't ibang klase ng kinds of first order ODEs. So unang-una dyan syempre is yung separable na equations natin. So siguro daanan lang natin maybe 1, 3, number 1 tsaka number 3 na lang siguro. So lipat lang ako sa aking whiteboard. May I ask if nakikita ba yung Microsoft whiteboard? Yes. Okay. Lock ko lang din to para di siya gumalaw. Okay, so let's start with this differential equation muna. So sabi niya dy over dx is equal to 4x times square root of y. So ang idea natin with the separable, variable separable na differential equation is that yun nga, kaya nating i-separate yung equation into something na yung nasa left in terms of x, then yung other side natin is in terms of y. So essentially yun lang naman yung gagawin natin. Meron tayong dy over dx dito, pwede natin siyang hindi siya pwede, pero parang ganun yung ginagawa natin. Dinidescribe natin siya in terms of dun sa differential or yung dy tsaka yung dx natin. So parang papaghiwalay natin yung dy over dx para meron tayong dy on one side and then dx on the other. And then ang gagawin natin is separate lang natin yung mga terms dito. So yung dx, lagyan natin dito yung mga in terms of x. So pwedeng yung 4x, stay na lang natin dyan. And then si square root of y dito, lipat natin sa other side. So malipat natin siya by dividing it by square root of y. So magkakaroon tayo dito ng 1 over square root of y. So rewrite ko lang. So that would be 1 over square root of y is y raised to negative 1/2. Y raised to negative 1/2 dy equals 4x dx. And then saka natin siya integrate both sides. And then ayun, proceed lang tayo with our typical integration na ginagawa sa Math 20 series. So y raised to negative 1/2. So ang integral niya would be y raised to 1/2 over 1/2. Tama ba? And then yung other side natin, 4x, that would be 4x squared over 2. And then dahil nag-integrate tayo dito, or dahil indefinite integrals to, so essentially dapat meron yung constitutive integration. So isipin nyo lang, para nag-integrate ka dito, meron kang plus c dito, nag-integrate ka dito, meron kang plus c dito, pero wala pa naman tayong idea kung ano yun. And present naman sila on both. So pwede natin silang kumbaga i-compile together para magkaroon tayo ng isang constant dyan. So meron tayong plus C. So if gusto niyo simplify niyo yan, pwede natin itong simplify siguro. Magiging 2 ito, and then magiging this becomes 2. Okay, so that is 2 y raised to 1/2 equals 2x squared. 2x squared plus c. And then, ayan, etong equation na to, this becomes yung kumbaga parang pinaka-general na solution natin. Kung wala tayong given na initial condition dito, which is in this case ito, y of 0 equals 1, ito na yung pinakasagot natin. Pero dahil meron tayong given dito, so kailangan nating tanggalin tong c na to, tong integration constant natin. So that's as easy as substituting x equals 0, then y to 1. So that is 2 times 1 raised to 1/2 equals 2 times 0 squared plus c. You would get a value of c that is equal to 2. So yung pinaka-final na equation mo, so that would be 2y raised to 1 squared plus 2. So ito na yung pinaka-equation na describe, or ito yung kumbaga solution ng ating differential equation. If ever kailangan nyo ng y as a function in terms of x, pwede naman natin siyang i-rearrange. So we can divide 2 dito and then square lang natin. So magiging y of x, that becomes, kung i-divide natin yung 2 dito, mag-cancel out lang din yung 2 dito. So that becomes x squared plus 1 quantity squared. So yan. So ito yung kumbaga nagdi-describe ito. This function describes itong behavior na to. So yun, ganun lang ka yung natin. Ganun lang kasimple, I guess, ating differential equations. Ayan. So do you have any questions so far? Yan, tama naman yung integration ko. Okay. Just making sure. No questions? Sige. I guess yun naman so far yung problem natin. Wait lang. Ayan. So okay, let's try sige, let's try number 2 siguro. Number 2. Hindi, sige. Hindi, madali na pala yung number 2. Ito na lang. Kung nasa baba na lang. So, determine natin tong solution ito. Ito, differential equation na yan. We transfer here. Lipat ka lang sa side. And, ayan. And there. Okay, so for this one, medyo mukhang complicated siya. Pero actually, kaya naman to. Wait lang. Check ko lang yung solution ko. Separable to. Yes. Oo. So, at first sight, siguro baka hindi siya mukhang separable. Pero with a proper substitution, actually magiging separable yan. Actually, yung mga susunod din, ganun din yung idea natin kung bakit meron tayong mga quote-unquote formula para dun sa mga sunod na types ng ODEs natin. So, dito, okay, so pinaka na-observe ko personally, or kayo, baka napapansin niyo rin siguro, na evident dito ay para meron kang U over V na na present dito. So, let's try that. So, siguro we let Y equals U over V. Okay? Taking note here na yung U natin ay isang function in terms of V. So, yung V natin yung ating independent variable, yung U natin ay dependent variable. Okay? So, bukod dyan, so after nito, meron tayong Y. Kailangan din nating masubstitute to somehow. Itong du over dv. So, gawin natin is differentiate natin to. So, magkakaroon tayo ng dy over dv. So, taking note, okay, yung u natin is a function in terms of v. Yung v ay isang function in terms of v. So, you need to perform quotient rule dito or quotient. Gagawin ko na lang dito ay product rule. So, left ko is u, yung right ko is 1 over v. Para mas, I guess, mas madali yun sa akin dito. So, left d right. Okay. Product rule lang to. So, left is u. Derivative ni right. Derivative ni 1 over v ay negative 1 over v squared. 1 over v squared. And then plus right d left. So right is 1 over v. Ang left natin is yung derivative ni u with respect to v, which is du over dv. Okay? So, gawin natin para masubstitute natin siya dito sa equation, i-rearrange lang natin. So, magkakaroon tayo dito ng dy lang. So, this becomes dy over dv. Then, meron tayo ditong negative. So, magiging positive yan. Plus, gawin ko is ganito. Baliktarin ko lang para alam ko na yung u, ito kasi yung dependent variable. And then, that is equal to 1 over v du over dv. Tapos, gagawin natin is multiply natin with v para magiging v to. And then, tong v squared ay magiging v na lang. Ayan. Du over dv is equal to this whole thing. Yan. So, substitute natin to. Okay, gamit ng ating sinubstitute na y equals u over v. So, una, du over dv, that becomes this one, itong buong to. So, that is v. Yan. Di ba tayo mawala yung isang v? Isang v. Yan. Okay. Never mind. So, d over dv is this whole thing. So, that is v times dy over dv plus 1 over v times u. Okay? Yung buong yan. And then, this one, okay, meron tayong v over u. Okay? V over u, reciprocal lang nito ni u over v. So, pwede natin siyang gawin na 1 over y. So, meron tayong 1 over y dito. Then, e raised to u over v, that is e raised to y. And then, minus y. Wait lang. Meron pa akong kulang dito na hindi na sa substitute. So, meron pa tayo ditong u. Okay? And again, u is equal to, gamit ng substitution natin, that becomes y times v. Okay? So, that is y times v. So, magkakaroon pa tayo dito, magkakancel pa tayo ng v dito. So, this becomes just y. Okay? 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 Get so far? Nakakasunod pa? Sige. Ayan. So, papansin kayo, meron tayo ditong plus y. Tapos meron tayo dito minus y. So that would actually cancel out. And matitira tayo ng v dy over dv equals, lipat natin to sa kabilang side, 1 over y e to the y. And that is separable na. So, ilipat lang natin tong y e to the y, papuntang left-hand side, tong v dv, v over dv natin, lilipat natin siya sa right-hand side para papunta to sa numerator. So, that becomes y e to the y dy equals dv natin, pupunta siya sa numerator. And then, tong v natin ay mapupunta sa denominator. 1 over v dv. And then, integrate nyo lang yan, both sides. Okay, so that becomes, sige, dito na lang sa tabi. Okay, so y e to the y, perform kayo dyan ng integration by parts. If I'm not mistaken, that is, sige, para hindi tayo masyadong mabilis. uv minus integral ni v du siya. So, wait lang, weird na may u tayo dito. Pero sige, siguro, lagay ka lang kayo dito. fg minus integral ni f dg uv v du. Hindi, gdf pala, sorry. Yeah, never mind. uv vs v du na nga lang. uv minus integral ni v du. Tapos ang u natin is, u natin would be y dv natin would be e to the y, du becomes dy, v equals e to the y. Ayan. So, using this substitution, so itong integral ni y e to the y, that would just be y e to the y minus integral ni, may dy ito dapat, integral ni v du, e to the y dy. Okay, so ito yon, kung magiging this one. And pag in-evaluate nyo itong integral, that would just be e to the y. So that is y e to the y minus e to the y. And then yung sa right-hand side natin, integral ni 1 over v is, if I'm not mistaken, is ln. Ln absolute value of v. And then add nyo lang yung integration constant natin dito. And yan, halos patapos na tayo. So last step na lang natin dyan is to substitute back yung inlet natin na y, which is u over v. So final answer mo, u over v, or yung final solution natin, e to the u over v minus e to the u over v equals ln absolute value of v plus c. Wala naman siyang given na initial condition. So, yeah, pwede na yan. Okay. Do you have any questions so far? Yeah, lang. Zoom out na. Yung 1 at 0 po. Hindi na gagamitin yung values. Okay. Yeah, meron tayong values na, okay, 1 at 0 according sa ating slides. Okay. Lagay natin siya. So, meron tayong u equals 0, v equals 1. So, what we will do is just substitute them. So, u equals 0, v equals 1. Yan yung given sa atin. So, dali lang naman yan. I-substitute back natin. So, u over v, so that is 0 divided by 1. That would become 0. E to the 0, that is 1. And then equals ln of 1. ln of 1 is 0. then C. So C natin is equal to -1. So yung solution natin would be U over V e to the U over V. Kung medyo tamad kayo, i-group natin siya, -1, ganyan. E to the U over V equals ln V minus 1. Ayan. So, ito yung ating solution for that differential equation. Ayan. Nakakasunod ba so far? Ayan. Do you have any questions? Ayan. Ito yung isa sa mga ways kung paano possible na humirap yung mga exams ninyo. Yung mga tipong hindi direct, may mga kailangan kayong i-substitute or i-let na mga something. Tapos, ayun, magiging pagka-substitute nyo na magiging regular na problem na lang siya. So, ayun. Okay. So that's it. Siguro yung other problems, provide na lang yan ni PSME sa inyo. If may solution sila dyan. Sige, proceed tayo dun sa other kinds of ODEs natin. So, ito naman, yung gamitan natin ng integrating factor. So, integrating factor yung sinasama natin or minumultiply natin para magiging separable yung ating ODE. So, nakalagay ba dito? Okay pala. So, yung form ng solution niya, okay? So, kunwari given tayo ng so kung first order na ODE siya, meron siyang form na okay. So, yung form ng solution natin ay given by y of x is equal to 1 over mu of x times integral ni mu times g dx pala tong dx plus c. Ayan. If I'm not mistaken, sa other materials, naka-express to in terms nung initial conditions natin. Pero hindi lang ako comfortable na nag-integrate ka from x not to x, I guess. So, I prefer this form. Tapos saka na lang ako mag-substitute kapag meron akong initial condition. So, ayan. Wherein si mu of x, yan, nakalimutan ko pala, yung ating integrating factor. Si mu of x yung ating integrating factor, which is given by e to the integral ni p of x dx natin. So this one, itong integral ni p of x dx, technically meron yung plus c pa, pero tinitake na lang natin siya na c equals 0 para mas madali nyo siyang i-plug in later. Kasi kumbaga hinahanap nyo lang naman yung function para maging variable separable siya. So, ayun. Let's try to find the analytical solution for, I guess, wait lang, yung ginawa ko earlier. Sige, let's start with 1 na lang siguro. I guess madali lang to. Kunin ko lang. Yan. Okay, so whiteboard ako naka-share. So, ang pinaka shortcut, pinaka-shortcut dito is i-translate mo 'to or rearrange mo siya into this form, kunin mo si mu of x, then kunin mo si y. Gano'n lang siya kadali. And then substitute mo yung initial condition para makuha mo si integration constant dito. So, ayun. So, ang gagawin natin gano'n nga. So, take note dito, yung y yung ating dependent variable, then x yung ating independent variable. So just in case na hindi dy over dx, para maging dv over dq to. So I hope ma-pick up nyo kahit na iba yung mga letters dito, kung ano yung mga corresponding variables dito sa form natin. So rearrange natin siya into this form. So that is dy over dx. That is dy over dx. And then meron ka ditong plus some function of x in terms of y. So yung meron ng ganun is itong plus xy. So lipat natin siya sa kabilang side. So that becomes minus xy. Minus xy. And then wala na natira. So equals. Then g of x, some function in terms of x. So nagmamatch naman siya dito. Okay, so ito yung ating rearrange form na fina-follow to. So this one is a next kunin natin si P tsaka si G. Okay, so from this pattern or from this one, mamatch lang siya dito sa pattern ng ating form ni linear ODE. So si P of x natin is kung ano yung nakakabit kay y, which is negative x. And then si g of x natin is kung ano yung nasa right-hand side ng equation, which is x. Then, ayun. Next, kunin natin si integrating factor, si mu of x. That is just equal to e times integral ni p of x dx, wherein yung p of x natin is x. So that is e to the integral of x dx, which is e to the x squared over 2. So, yan yung ating integrating factor. Wait lang. This should be negative. Yes. Ayan. Okay, so meron tayong integrating factor na e to the negative x squared over 2. I-substitute natin siya dito. So, y of x natin, y of x equals 1 over mu of x. So, 1 over this one. So, that would just be, cancel lang yung negative sign niya. So, that would just be e to the x squared over 2 times integral ni mu times g of x dx. So, meron tayo ditong mu natin is e to the negative x squared over 2. G natin is x. And then dx. Yan. If makakalimutin kayo sa plus c, kanya siya ilagay dyan. If hindi naman, okay lang na wala yan. Pero ako, makakalimutin ako. So, yan. Better safe na lang. So, kailangan kong evaluate tong integral na to. So, e to the negative x squared over 2. So, nagawin ko u equals negative x squared over 2. And then du is equal to negative x dx. So, sakto. Sakto siya dito sa ano natin, sa ating differential equation. Yung pala, trick I guess, if trick din siguro na if baka masyadong complicated yung sinasolve nyo, baka mali kayo. Though I don't know, di ako sure kung sobrang applicable ba yan sa eng. Ayan. So, i-substitute natin to. So, that would be, lagay natin lahat para di tayo lost. E to the x squared over 2 times integral ni e to the u, since in-substitute natin yung buong exponent ni e, and then x dx is negative du. So, negative du plus yung constant natin. And this one, integral ni e to the u is just e to the u. So, that becomes e to the x squared over 2 times negative e to the u, wherein yung u natin is negative x squared over 2. Negative x squared over 2. Ganyan natin yung square na yan para di tayo malito. So, e to the negative x squared over 2 plus c. Okay? So, dahil pareho naman to, I guess we can distribute this para mas maganda yung form ng ating solution. So, that becomes this one times this is 1. Dahil pa nagmumultiply tayo ng exponents, hindi pala nagmumultiply ng exponents. Multiply ng, natawag dito. Basta terms of exponent, pinag-add natin yung exponents. Ayan. So, x squared over 2 minus x squared over 2 is 0. E to the 0 is 1. And then take note na lang na meron tayong negative dito. So, that is minus 1. Then, meron tayong c dito. Plus c times e to the x squared over 2. So, ito yung ating, kumbaga, general na solution natin. Plug in natin yung ating initial condition na y of 0 equals 2. So, if x is 0, yung y daw ay 2. If x is 0, yung y ay 2. So, magiging 2 ito. Tapos yung x natin magiging 0. 1 plus c times e to the 0 squared over 2. 0 squared over 2. Okay, so e to the 0, that becomes 1. So, c natin is 3. So, that is just 2 plus 1 since hindi pa natin yung 1 dito sa kabilang side. So, yung solution natin for this differential equation is y of x equals, unahin natin to. So, 3e to the x squared over 2 minus 1. Okay? Ayan. Do you have any questions so far? Ayan. Zoom out natin para makita yung buong flow. Gana ba yung integrating factor method kahit anong first order ODE? Hindi. Nagana lang siya kapag linear yung first order ODE mo. So, linear, take note na natin yung linear na first order differential equation ay yung isang differential equation wherein wala kang naka-square, naka-square root, naka-tangent, sine, cosines, naka-ln, exponential dun sa dependent variable mo. Okay? Yung independent variable mo, okay lang na nakapasok siya sa kung anumang function. Pero yung dependent variable, so kunwari, meron kang dy over dx na naka-square. Hindi na yung linear. So, hindi siya gagana dito. Pero basta, gagawa mo siya into this form, malilipat mo siya into this form, it will always work. Ayan. Can you do one in the form ng mdx plus ndy equals 0? Wait lang. Meron ba kayong pinrepare na problem doon na related? Wait lang. Medyo hassle siya, pero sige. Sige, hanap. Meron ba kayong maybe baka meron kayong problem na dyan para di na ako mag-search. Kasi this one, I think hindi to exact. Hindi to exact kasi 'di ba ang partial derivative dito with respect to y is y squared tangent x. Partial derivative nito with respect to x is 0. So hindi to number 3. Sige, try ko mag-isip ng problem siguro. Pero hindi ako mag-deal ng partial derivatives ngayon. Pero sige. Daanan na lang siguro natin later pagka may time tayo dun sa exact na ODE. Sige. Any questions muna ulit before tayo mag-proceed? Sige. Tong other, sige. Puntahan na natin tong number 3 dahil medyo special siya. Okay, ayan. Okay, so ito, baka isipin nyo, yun nga, sabi ko kanina, baka isipin nyo na baka pwede yung exact, yung sa exact dito, or baka exact na ODE ito, kasi nakaseparate yung dx tsaka dy, pero hindi, kasi, diba, kailangan, ano ba yung form natin dito? Yung m, ito yung m, tas n nga ba, or pq yata. Pero kailangan mong kunin yung partial derivative dito with respect to y. Kailangan kunin yung partial derivative dito with respect to x. Dapat equal sila. However, partial derivative nito with respect to y is, yun nga, y squared, negative y squared tangent x. Partial derivative dito with respect to x is 0. So, I think hindi to exact. However, pwede tayong divide yung dx natin dito, then kakaroon ulit tayo ng some regular function ulit, or some regular na ODE dito. So, rewrite na lang natin to. So, negative y squared, y cubed, sorry. Y cubed, tangent of x, plus 1, all over 3, plus y squared, dy over dx. Again, yung mga ways kung paano nagiging hassle or mahirap yung mga problems ay sa pamamagitan ng mga indirect na kailangan yung gawin na substitution. So, this one is also another example of that. So, kahit i-try nyo, you can try, I guess, pwede nyo siguro i-try ito na i-transfer dun sa form natin dito. This one. So, wait lang. Copy ko lang siguro to. Yan. Copy para kita niyo dito. Pag nag-divide tayo ng pag nag-divide tayo ng y squared dito, magkakaroon ka dito sa constant dito ng term na na merong 1 over y squared. So, hindi mo siya ma-express into this form. So, paano natin gagawin to? So, ano ba yung mga ways na pwede natin gawin para mawala siguro yung y squared or yung y cube or kung ano man. Ang gagawin natin is substitution again. So, let me use w na lang para dun sa variable na yon. So, ano ba yung mga magandang pwede natin gawin dito? Pinaka naisip ko ay y cubed over 3. Bakit y cubed over 3? Para ito, ilipat ko agad dito, magiging w lang siya, yung part na yan. Tapos, plus 1/3 lang dito. So, baga pagka sineparate ko, ayan. Tsaka para pagka dinifferentiate ko siya, mawala yung 3 dito. So, kung di-differentiate natin to, with respect to x, taking note na yung w is a function of y, wherein yung y natin is a function in terms of x. So, meron tayong dw over dx, that is yung derivative nito ng buo, which is 3y squared over 3. So, magiging y squared siya. And then, magmumultiply tayo nung derivative nung function na yan. Chain rule lang. dy over dx. Okay? So, etong term na to is as easy siya as dw over dx. And then, yung y cube over 3, mapapalitan agad natin siya ng w dito. So, rewriting it, kami itong substitution natin. So, magkakaroon tayo ng, i-separate ko na yung dalawang terms dito. Okay? So, magiging negative w tangent x. And then, meron tayo dito minus 1/3. Minus 1/3. And then, meron tayong plus dw over dx equals 0. Ayan. So, eto, mas malapit na siya dito sa form na to natin. So, rearrange na lang natin yan. So, dw over dx, ito yon yung derivative na to. Yung meron naka-multiply na meron tayo ditong function in terms of x, tapos naka-multiply yung dependent na variable. Ito yon, itong w tangent x yon. So, magiging dw over dx tayo dito minus ito yung function in terms of x, tapos ito yung ating dependent variable. And then meron tayong g of x dito. Ito not necessarily in terms of x, pero pwede na yan. So, ayan. Nabalik na natin dito sa form na to, wherein si p of x natin is negative tangent of x, and si g of x natin is 1/3. Ayan. In terms of x pa rin naman daw, x raised to 0. Ayan, tama naman yung sinabi ni ating ni Evangelista. Ayan. So, break lang tayo dun sa ano natin. Kunin natin si integrating factor. So, mu of x is just e times e raised to the integral of p of x dx, or e raised to the integral of negative tangent x dx. So, ano yung integral ni negative tangent x dx? Ni-memorize naman to, no? Or ni-usab nyo pa rin to? Ito muna. Yung integral lang muna. Integral ni negative tangent x dx. Hala, lagot, di na alam yung ano, integral ni tangent x. Ayan. Okay. So, tama yun. If I'm not mistaken, ln absolute value of cosine. So, if I'm not mistaken, that is negative. Hindi. Integral ni tangent x is ln of secant. Tapos meron tayong negative, which is just pagka pwede mo siyang ilagay sa ln, magiging 1 over, ano lang naman yun. So, magiging 1 over secant siya. So, that becomes e to the ln of cosine x. Okay? And e raised to ln of cosine, e raised to ln of cosine x is just cosine x. So, yan yung ating integrating factor. Okay? So, yung ating w, since w pa yung sinosolve natin, is 1 over cosine x times integral ni mu cosine of x times g, which is 1/3 dx. And then meron tayong plus integration constant. So, integral ni cosine, excuse me, ang integral ni cosine of x is sine of x. Walang negative. Wait lang. Sorry. No, walang negative. And then mag-multiply na tayo ng 1/3. So, that is w of x equals 1 over, lang. Sulat ko siya ng mas maayos. W of x equals 1 over cosine of x times 1/3 sine of x plus c. Okay? And ito yung ating w. Pero ang kailangan natin is y. So, yung w natin is equal to y cubed over 3 as per our substitution. So, substitute natin siya, evaluate natin siya pabalik. So, that becomes, so, y of x cubed over 3 equals, siguro i-ano na natin to, distribute na natin yung 1 over cosine x. So, meron tayo ditong 1/3 sine over cosine is tangent of x. And then meron tayong plus c, excuse me, c times 1 over cosine, or pwede natin sabihin na secant of x siya. Yan. So, if ever kailangan nyo ng y mismo, y as a function of x lang, so pwede natin siyang manipulate na lang ulit, multiply natin yung 3, and then kunin lang natin yung cube root. So, this becomes y of x equals 3 over 3, that is 1, tangent of x. Itong c na to is an arbitrary constant since wala pa naman tayo ditong condition na given. That could be any number. Any number, multiply mo lang sa 3 is still some arbitrary number lang din. So, pwede siyang C pa rin yan. Or if ever uncomfortable kayo, pwedeng gawin yung D or some other letter siguro. So, siguro yan. Gawin na lang natin D para hindi uncomfortable sa mga tao na medyo maarte sa math nila. So, sabihin nila lang na D equals 3C, ganun. And then, yung cube natin dito, cube root lang natin. And then, ayan. So, ito yung magiging solution natin for y of x. Okay. Are there any questions? And so far? Okay, sige. Ayan. So ayun, para dun sa mga differential equations natin na kaya natin i-solve using the integrating factor. So lahat naman yata to linear. Yan. So pwede yan. Or magiging linear. Sige. Kasi tayo dun sa ito yung unit 2 dun sa mga second order ODEs natin. So yung idea natin, yung idea ng second order ODEs natin ay wait lang. Okay. Sige. So ang second order na ODE ay mga ODE na kung saan yung ating derivative ay instead of first derivative yung highest, ay meron tayong second derivative. And ang ah, ang masaklap doon or ang masakit doon ay possible na meron pa rin tayong first order derivative. Kasi kung second order derivative lang yun nandun, baka kaya natin siyang i-solve using ah, yung mga ginagawa natin before. So para mag-integrate ka lang twice. However, yun nga, may mga instances tayo na kung saan hassle or meron tayong first derivative, meron tayong second derivative. At nandun din yung mismong function. Kaya meron tayong ganitong form. Yung solution natin sa mga ganitong equations ay actually madali lang siya. Madali lang siya provided na yung A1 tsaka A2 natin ay mga constants. Okay? So ito, itawag din natin siya na second order linear differential equation with linear homogeneous. Okay? So ang haba, no? Linear homogeneous differential equation with constant coefficients. Okay. So homogeneous naman siya dahil yung term natin dito ay 0. So kapag meron tayong function in terms of x na multiply pa dito, magiging non-homogeneous or inhomogeneous na siya. Kapag yung A1 at A2 natin nagkaroon yan ng function in terms of x, medyo mahirap yon. May ilan na kaya pa yata natin i-solve analytically pero yung ilan, ang solution niya ay isang series, yung iba, hindi talaga. Mahirap i-solve. So, yung pinaka-idea natin dito para ma-solve yung ating mga itong equation, knowing na A1 at saka A2 natin ay constant lang naman, is hanap tayo or mag-isip tayo ng function na kung saan yung y natin, yung derivative niya, tapos yung next na derivative niya ay somewhat ma-express mo ng pare-pareho para pwede mo silang pag-add, pag-subtract, at ma-match mo sila para maging 0 nga yung ating itong left-hand side natin. And yung function na yon ay yung exponential function. Dahil pagka kinuha mo yung derivative nito, magre-remain yan, mag-stay yan. Okay? So, yan, tuloy dito. Pag sinubstitute natin itong y equals e to the rx dito sa ating differential equation, okay, so y prime is e to the rx times r. Kaya ito siya. Kaya naging ito yung term natin dito. Yung a1 y prime, naging ganito siya. And then pag kinuha mo yung second derivative ni y, nagiging r squared e to the rx lang siya. Kaya ito siya. Okay? And yan, present lahat ng e to the rx natin. And para maging 0 siya, kailangan yung r squared plus r a sub 1 plus a sub 2 ay maging 0. And then, ayun. Ganun yung pinaka-idea natin. So, kailangan nyo i-solve si r natin. So, ayun. Meron tayong 3 cases para dun sa ating r. Okay, since this is a quadratic equation, pagka meron tayong real at saka distinct na roots, so meaning magkapareho, ang form ng solution natin ay C1 times e to the R1x plus C2 e to the R2x. So, kung ano yung nakuha nating R, substitute yung R, ibabalik nyo lang dito, then multiply lang R, multiply lang tayo ng ating integration constants dito. Okay. So, dalawa na yung integration constants natin dito dahil second order yung ating differential equation. So, parang isipin nyo na nag-integrate kayo twice. Second case, kapag repeated yung na-obtain nyo na root. So, kapag repeated yung root, ibig sabihin real din yon. So, pagka nakuha nyo siya, so, di ba, ang quadratic formula natin, negative b squared plus minus square root of, negative b plus minus square root of b squared minus 4ac. So, kapag nag-zero yung all over 2a. So, kapag nag-zero yung discriminant natin, so, isa lang yung makuha nyo sagot. So, and sure yan na real. So, kapag repeating yung roots natin, so yung form ng solution natin would be in terms of this. And then kapag yung obtain natin na roots ay complex, so kapag eto, okay, so yung form ng complex natin ay ganito. So parang a plus minus bi. So yung a natin yung lambda, yung b natin is yung mu. Yung magiging form ng ating solution ay ganito. May exponential, then dito yung cosine at yung sine. Okay, so yung C1, C2, AB, lahat yan, yun yung ating mga arbitrary constants natin na nakukuha mula doon sa integration. So, ayun. Di naman to class, so di natin di-derive kung bakit ganyan yung mga form ng solutions natin. So, sige, try natin to. Tingnan natin kung kaya natin to lahat to. Kasi mabilis lang talaga pagka homogeneous yung ating differential equation. Wait lang. Ayan. So, start tayo with number 1. So, y double prime minus 7y prime plus 12y equals 0. Y of 0 equals 2. Y prime of 0 equals 5. So, ano sabi natin to? Meron tayong natawag na characteristic equation. So, ito yon. Ito yon. Ito yung ating characteristic equation. So, para mabuo mo siya, nang hindi natin parang dinadaanan yung buong process na yon. Isipin niya lang kung ano yung order ng derivative. Okay, yun yung exponent ng magiging characteristic equation. So, start tayo with number 1. So, yung characteristic equation natin dyan is, okay, so this one is naka-double prime. So, yung ating yung exponent nung kinukuha na natin ng characteristic equation ay 2. So, r squared. And then minus 7 y prime. So, 1 lang raised to 1. So, r raised to 1. And then meron tayong plus 12y. So, hindi ito wala tayong derivative dito. So, that becomes just plus 12 equals 0. Then, solve nyo lang yan. So, dito, so makakuha ka ng r, which is equal to, that is r minus 4, r minus 3, di ba? So, that is, di ba 3, 4? Okay. Ayan. Okay. Just in case lang, hindi tayo, baka feeling nyo masyadong tayo mabilis. So, factor nyo lang to. So, that is r minus 4, r minus 3 equals 0. Kaya yung r natin is 3 and 4. Okay? So, dahil meron tayong real na magkaibang roots, so yung magiging solution natin, So y of x is equal to c1 e to the 3x plus c2 e to the 4x. So yan yung ating pinaka-solution or yung parang general na solution natin. Sorry. Hindi ako doon sa general kasi meron ito rin general solution din siya ng pagka inhomogeneous. Ayan. So next gagawin natin is kunin lang natin yung ating integration constant C1 and C2 gamit ng ating initial conditions. So kunin na lang muna natin si y prime. Okay, so that is just 3c1 e to the 3x plus 4c2 e to the 4x. Apply natin yung initial conditions natin. Y of 0 equals c1 times e to the 3 times 0. So e to the 0, that becomes 1. And then plus c2, ganun din siya. Multiply na tayo sa 1. And that is equal daw kay 2. And then meron tayong y prime of 0, which is equal sa 3c1 times 1 plus 4c2, which is equal sa 5. Kasi 5 to. Okay? So, ayan, kaya niyo naman yung i-solve by hand. Kaya niyo i-solve using your cycles. Ako, I will solve it using my cycle. Dahil di ako mabilis mag-solve ng mga ganyang bagay. 3, 4, 5. Ayan. So, C1 is equal to 3. Then C2 equals -1. Tama ba? Okay. So, yan yung value ng ating arbitrary constant. So, yung complete na solution natin for this ODE is y of x equals 3 e to the 3x minus 1 e to the 4x. Okay. Okay, get so far? Sige. Next, proceed tayo sa number 2. Lagay ko na lang dito sa tabi. So again, same procedure, same process. Buuin natin yung characteristic equation, which is just y double prime. So magiging r squared to, tapos minus 2y prime. Magiging minus 2r siya sa ating characteristic equation. And then meron tayong plus 5y. Plus 5 equals 0. And then, yan. Solve lang natin yan. I think this is factorable. Factorable ba to? Hindi. 5-1 lang pala yan. Okay, so mag-quadratic formula na lang tayo. So r equals negative b. So that is negative 2 plus minus square root of b squared. That is 4 minus 4 times 1 times 5. All over 2 times 1. So yan. Solving it. So that is 2 plus minus 4 minus 20. 4 times 5 is 20. That is 16. So this is negative 16. So negative 16, ang square root ng negative 16 ay 4i all over 2. Or as easily as 1 plus minus 2i. So yung roots natin dito ay complex. Okay? So ang magiging form ng solution natin would be may exponential dito. Exponential, and then dito nakakabit yung ating real part. So, e to the 1, x, tapos meron tayo nakamultiply na cosine tsaka sine. Gawin ko tong square bracket. C1 cosine. Okay, tapos dito naman lalagay natin yung imaginary na component ng solution, ng roots natin. 2x plus C2 sine 2x. Okay? So yan yung pinaka general solution natin. Substitute niyo lang yung ating we're going to just substitute yung ating initial conditions. So y of 0, then yung y prime of 0. So kailangan natin tong kunan ng y prime. So left, derivative ni right, e to the x. Derivative ni right is, derivative ni cosine is negative sine. So that is negative 2c1 sine 2x. And then dito, that is 2c2 cosine 2x. So that is left di right plus right derivative ni left, which is the same. Dito plus e to the x c1 cos 2x plus c2 sin 2x. Substitute natin yung initial conditions natin. Y of 0 equals what? Y prime of 0 equals 0. So starting with the first equation, yung sa y of x natin, y of 0 equals 1. So yung y natin magiging 1 equals yung x natin magiging 0. So e to the x or e to the 0, that becomes 1. So parang mawawala lang din to. Tapos meron tayo ditong c1 cosine of 2 times 0. Cosine of 0 is 1. So meron tayo dito C1. Sige, lagyan na lang natin siguro para di kayo malito. So e to the 1x or e to the 0, that becomes 1. C1 cosine of 2x, that becomes 1. Plus C2 sine of 2 times 0 or sine of 0, that becomes 0. Okay? So dito pala makukuha natin na C1 is equal to 1. And then para naman doon sa y prime, ganun lang din yung gagawin natin. So y prime of 0 is 0. So that is 0 equals e to the 0 is 1. And this becomes negative 2 c1 times 0 plus 2 c2 cosine of 0 is 1 plus 1 c1 cosine of 0 is 1. And then c2 sine 0 is 0. Okay, so alam natin na c1 is 1 from here. So pwede i-substitute na lang siya dito. So that is 0 equals, na naman tayo pa dyan sa 1 na yan. So meron tayo matitira dito na 2c2, which is ito, plus c1. c1 is 1. So c2, that is, this is positive. Not mistaken. Yes, it's positive. Bakit siya may nakita ganyan? So C2 natin would become negative 1/2. So yung ating complete solution for this is e to the x times C1 is 1. So that is 1 times cosine of 2x minus 1/2 sine of 2x. Okay. Do you have any questions? Okay, so ito yung sa inhomogeneous, actually madali lang yan. Pero let's proceed muna dito. Yung solving ng initial value problems using Laplace transform. So Laplace transform isa siya sa mga ginagamit din natin to make things easier kasi instead of integrating, excuse me. So instead of actual integrating, medyo mas algebraic yung approach natin dito. So ang idea natin pagka gumagamit tayo ito yung definition ng Laplace transform. So essentially, tina-transform mo siya from a domain ng T papunta sa S natin. Okay? So ito yung definition niya. And yung way ng pag-approach natin dito is pag-approach ng problem natin is ita-transform natin yung equation pumunta doon sa Laplace to Laplace, and then i-solve mo lang siya, and then that would just be using algebra, and then ta-transform mo siya pabalik pupunta dun sa inverse Laplace. So detail natin siya later. And ayun, dahil nga isa to sa mga mostly na ginagamit, especially pagdating nyo sa systems natin, pag model ng mga systems, meron tayong ito, table ng mga common na Laplace transforms. So essentially, pagka meron kang ganyan, pagka meron kang nakitang e to the constant times t, yung Laplace transform niya is automatically ganito agad yung form niya. And then ganun din doon sa mga other elementary functions natin. Okay, so again, ito nga, steps natin. So take natin yung Laplace transform of both sides ng ODE, apply initial conditions, then separate terms, using approaches like yun nga, partial fraction decomposition para mag-correspond yung mga makukuha nating sagot into this form para ita-transform natin pabalik. Marka hindi nasama dito, which is yung Laplace transform ng derivatives. Sige. Try na lang muna natin to. Siguro 1 muna. So bakit ginagamit yung Laplace transform instead of yung mga other methods na na-discuss natin? Ay dahil nga algebraic lang yung approach niya, dahil ang Laplace transform natin ng derivative, so yan yung symbol natin, that would be x prime of t, siguro yan na lang, ay nasa form na nakapamalit nito. So that would be s times yung Laplace transform ng function natin minus x of 0. Tama ba? And then yung second derivative naman, that would be s squared x of s minus s x of 0 minus x prime of 0. Yan. Yan yung form ng Laplace transform ng derivatives natin. So instead of derivatives, yung work on natin, ayan, itong x of s, okay, ito yung parang pinaka-function natin in Laplace, in the Laplace domain, in the S domain pala, sorry. Okay, so essentially, kailangan mo lang siyang i-isolate. So para ma-isolate mo siya, that is just algebra. So let's start with this problem. So dx over dt plus x was t. So kukunin natin yung Laplace transform nila. So kung kita niyo naman dun sa definition natin nung Laplace transform kanina, integral lang siya and yung integral ng isang sum ay same lang din sa integral or sum nung individual integrals. So, pwede mong i-transform isa-isa yung bawat term dito sa ating Laplace transform. So that is, start tayo with dx over dt. So that is just yung first derivative ng ating function. Okay, so that becomes this one. So, s times capital X of s minus x of 0. And then yung x natin dito, ang Laplace transform lang niya ay i-represent natin by capital X. Capital X of s. And then yung t natin, okay, pupunta tayo dun sa ating Laplace, yung table ng Laplace transforms. So, t, hanapin nyo lang siya dito. Yan. So, ano yung pinakamalapit sa form niya, which ito to, number 4. So, that is t raised to 1. So, that would just be 1 factorial over s raised to 1 plus 1. So, that is 1 factorial 1. S raised to 1 plus 1 is 2. So, that is 1 over s squared. 1 over s squared. Okay? So, para mas dumali yung buhay natin, okay? Since alam naman natin na yung initial condition, x of 0 equals 1, pwede nyo siyang i-substitute agad dito. Pwede siyang ganyan, 1. And para makuha nyo, okay, kailangan natin si capital X of s. So, isolate lang natin siya. So, meron tayong, if a factor out ko si x of s dito, so meron tayong s plus 1 times capital X of s equals 1 over s squared plus 1. Okay? Choice nyo yan kung gusto nyo na pagsama yan, tapos saka nyo ipaghiwalayin. And then yung ating function in terms of s is just 1 over s squared s plus 1 plus 1 over s plus 1. Okay? So, ito yun. Kailangan lang gawin natin dito is i-break down siya into simpler functions kasi yung table of Laplace transforms natin medyo hindi pala kumbaga may mga limited na forms lang siya. So specifically ito yung kailangan natin i-break down kasi wala tayong specifically na ganitong form. Meron lang tayo dito itong s plus 1, meron tayong para sa s squared, pero wala tayo pagkaganyan. So, break down natin to into using partial fractions. So, 1 s squared s plus 1, that would be a over s plus b over s squared plus c over s plus 1. Multiply nyo lang pabalik, that would be a s plus 1 plus b s plus 1 plus c s squared all over all of these s squared s plus 1. And then match nyo lang kung ano yung mga magkakasamang exponents dito. So that is para sa s squared, yun yung highest natin dahil s squared to. That would be a, ito, and then plus c. Wala tayong s squared dito sa part na to, so that would just be equal to 0. Para naman kay s, that is a again, ito, a. And then meron tayo ditong bs. Okay. And dahil wala tayong naka-s dito sa term natin dito, that would just be 0. And then meron tayong s raised to 0 or yung sa constant natin. So wala na tayong a dito dahil meron siyang nakamultiply na s. Meron tayong b. b times 1. And Sa C, wala na. And equal siya dito sa constant part ng ating numerator, which is 1. So, B equals 1. Makuha mo dito na A equals -1 para maging 0 siya. And makuha mo dito na C equals +1. Okay? So, breaking it down, meron tayong x of s, which is equal to A natin is -1, -1 over s. Meron tayong B na 1, so 1 over s squared. And then yung C natin is s plus 1. C natin is 1 pala, sorry. So meron tayong plus 1 over s plus 1. Pero kailangan pa natin itong isama. Okay? So meron pa tayong plus 1 over s plus 1 dito. Okay, kasi itong tatlong to is para lang dito sa term na yan. Since itong dalawa, itong s plus 1, 1 over s plus 1, pareho lang naman sila, pwede mo itong pagsama. So this becomes 2. And ito, i-refer niya lang pabalik dun sa ating table of Laplace transforms. Gusto ko lang itong plus sign. Okay, so start tayo. Sige, sulat na lang muna natin ito. X of t natin. So start tayo with -1 over s. Balik tayo dito. 1 over s. Ito yon. Ang inverse Laplace transform niya is 1. So, ilagay niya dito is -1. Okay? Next, 1 over s squared. Ito siya. Ito yung form natin dito. So, that would be n equals 1. 1 factorial s raised to 1 plus 1. So, magiging, yung n natin is 1. So, magiging t raised to 1. Siya dito. Plus t raised to 1. Okay? And then, meron tayo ditong 2 over s plus 1. 2 over s plus 1. So, yung 2, constant lang naman siya. So, ang pinaka-concern natin dun is yung 1 over s plus 1. So, may pinakamalapit na form sa kanya is ito. Okay? So, that is 1 over s minus a. However, yung nasa atin ay 2 over s plus 1. Or 1 over s plus 1. Saka natin isipin yung 2. So, yung a natin would be -1. Dahil s plus 1 eh. So, negative dito. So, magiging -1 yung a natin dito. And then yung 2 is i-multiply lang natin dito. Dun sa buong exponential term. So, that becomes plus 2 e to the -1 times t. So, ito yung complete na solution natin for that ODE. Okay? Do you have any questions? Yan, 7:27 na pala. So, I guess di natin kaya mag, siguro ng another problem. Yan, any questions? Any questions? Yan, isend ba yung PowerPoint? Kailan isend ba yung PowerPoint? Yes, yes daw, sabi niyo.
And the recording will also be posted on the PSME-UPSU YouTube channel.
Yan, sige. Yan, meron pa yung few minutes. Baka may questions pa kayo dyan. I think na-cover naman natin most parts ng ng pag-solve ng first and second order differential equations. So, actually, pwede nyo siyang i-mix and match-ish. Or like, pwede nyo gamitin yung other method kung sa tingin nyo pwede siya as long as nakasunod naman sa form. Or like for example, yung natin, yung first order ODE, if ever na homogeneous naman siya, pwede nyo rin siyang isolve using yung characteristic equation. Or ano ba? Pagka inhomogeneous, essentially, meron ka lang din idadagdag na tinatawag na particular solution para mag-solve naman doon. Laplace pang inhomogeneous bang Laplace, pwede rin siya for homogeneous differential equations. Pinakamapansin niyo lang kada nagdadagdag tayo ng term dun sa inhomogeneous part ng ating differential equation, dumadami lang din yung terms dun sa solution natin. Kasi kumbaga naghahanap lang kayo ng hinahanap mo lang yung function na kung saan mag-equal siya dun sa specific term na yon. Ayan, para malaman kung homogeneous or inhomogeneous. Pagka wala kang so ang differential equation mo, 'di ba, meron kang sabihin na lang natin na kung yung y natin is si dependent and then x mo is yung independent. Okay? Pagka homogeneous, so meron kang something dyan, something dyan sa equation mo. Okay? And then as long as wala kang function in terms of x na wala nakakabit na y, as long as equal 0 yan, homogeneous yung differential equation mo. Kapag meron yan, present yan, kesyo 1, kahit constant yan, okay, not equal to 0, inhomogeneous na siya. So, pagka inhomogeneous na siya, yun, kailangan mo na ng particular solution. Ito. Dun sa Laplace natin, nakukuha na rin niya pati yung particular solution. So, baka di niyo na siya hindi niya siya mapansin na kinukuha niya pa siya separately. Ayun, do we have other questions? Calling once, twice, thrice. Hearing none. Sige. Okay, so I guess that ends our review session for today. Good luck sa ME11 sa mga requirements ninyo, and ayun, I hope you learned something naman.